Okay, so finding the equation of the tangent line. So let's say you're given a function, in this case y equals 3x squared times 5x plus 7 squared, and they want you to find the equation of the tangent line at x equals to 4. So first thing you're going to do, you're going to find the derivative. The reason why I find the derivative is because, well, what is the derivative exactly? The derivative of an equation gives you the value of the slope of the tangent line at any point in that equation. What do I mean by that? Well, let's say you have an equation that looks like this blue line right here, right? Let's say this right here makes that blue line. It doesn't, like, it's not even close, but let's just pretend. Okay, so we have this equation right here. And so if we find, so we use the derivative, and then we find a derivative of the equation, right? So we find the derivative, it's right here, and you evaluate that derivative at x equals 4. By evaluate, I just mean you plug in x equals 4 into the derivative, right? And let's just say this red point right here is x equals 4. Let's just say this right here is 4. Okay? So the number you will get from putting in the x value into the derivative equation will be the value of the slope of this tangent line. And the tangent line, hopefully you already know this, is a line that touches a curve at this point without passing through it. It's the line that just touches the curve and doesn't cross through it at all. It doesn't, touch more than one point, just touches that point. So if you have the derivative of a function, you can find the value of the slope of the tangent line at any point at that function. And you might remember the equation of a line, right? Y equals mx plus b. I learned this in 9th grade, I believe, maybe 8th grade, I'm not sure. And if you remember this, right, m is the slope, right? So basically with the derivative, we're finding the m value. So if you have the derivative of this equation and you put in 4 for x, we are finding the m value of this line at x equals to 4. Hopefully that makes sense. So we're trying to find the equation of the tangent line. We have the slope, but we have to find everything else, right? We have to find b, which you may remember b is the y-intercept of the line. So to do that, okay, first of all, we're going to take the derivative, right? We found the derivative right here. So for this one, it's a product rule, right? We have 3x squared here, 5x plus 7 squared here. So I did a product rule. So u is equal to 3x squared, v is equal to 5x plus 7 squared, u prime is 6x. V prime, we have to do the chain rule here, right? Because 5x plus 7, and all that is squared. So chain rule. So we end up with 2 times 5x plus 7, right? Because we take this 2, bring it to the front. And then it's multiplied by 5 because the derivative of 5x plus 7 is 5. Of course, I'm going through this pretty quickly. If you still don't know the chain rule, then for one, you can go watch the video I made on it. Or if that's still not enough, then I would suggest just searching up other tutorials for it, because I'm trying to get through this stuff pretty quickly, so I don't want to spend a ton of time showing how to differentiate every single equation, right? So anyways, we have u, we have v, we have u prime and v prime. Apply the product rule. Y prime is equal to u times v prime plus v times u prime. And so we get this equation. So now with this derivative, we can find the slope of the tangent line at any point of our equation. In this case, we want to find that x equals to 4. So we plug in 4 for all the x values, and we get this big number, 30456. And this number is our slope of the tangent line at x equals to 4. It's the m value. And I specifically wrote 10 because it's tangent. I like doing that. It makes it easier to remember if you're also working with normal lines, which I'll get to in a second. So we have the slope, but again, we still need to find the whole equation of the line. We still need to find the b value. So to do that, we're going to use a very simple little equation right here. So the equation is this: y minus y1 is equal to m times x minus x1. So x1 is just the x value that we're given, right? So specifically, x1 is the x value of the original function at which we're finding the tangent line. So in this case, we're finding the tangent line when this function is equal to 4. But you might be finding the tangent line when, I don't know, x is equal to 2, in which case x1 would be 2. You might find it at any point, right? So x1 is just equal to whatever point at which you are finding the tangent line. And y1 is the same thing. It's the y value at whatever point that you're finding the tangent line. So in this case, we're only given the x value. So to find the y value at which we are looking for a tangent line, we have to take the x value that we're given for and plug it into the original equation, right? We're plugging into the original equation, not the derivative equation. If you plug it into the derivative equation, you're finding the slope of the tangent line at that point. But we're not trying to find the slope. We already found that. We're simply trying to find the point on the original function at which we're finding the tangent, right? So we're going to take x equals 4, plug it into this original function right here, and you end up with this big old number, 34992. So we have this equation. We plug in the numbers we just found. Y minus 34992 is equal to 30456 times x minus 4. So y1 was subbed in, and x1 was subbed in. So now I expanded right here, right? I took 30456, multiplied by x, and also multiplied by minus 4. You get this. So, and now the only thing you need to do is you want to isolate y, right? The equation of a line is typically given as y equals mx plus b. It's not always the case, but that's what I like to do. That's, if you do this, you should be totally fine, right? You'll get all the marks. Like, that's normal procedure. So you're just going to take negative 34992, move it to the other side. So right now it's on the left side, move it to the right side. So now we have just y on the left side. And we end up with this, right? Because 349. So negative 121,824 plus 34992 gets you 86832. My math might not have been perfect. I'm pretty sure I did it right, but it doesn't really matter, right? This is just a demonstration. And that's it. This is the equation of the tangent line at the specific point that they gave us, which is x equals 4 and y equals 34992. So that's that. And that's the tangent line. Now there's also the normal line. The normal line, in case you don't know, it's the, okay, so let's say this is our tangent line. The normal line is just the line that goes through the tangent line at a 90-degree angle. That's it. So it's perpendicular. That's another way to say it. So to find the normal line, you're going to take to find the slope of the normal line, sorry. So we have the slope of the tangent line. We want to find the slope of the normal line. All you're going to do is take the negative reciprocal of the slope of the tangent line. So what is a negative reciprocal? Well, look right here. Right now, the slope of our tangent line is 30456. So to find the slope of the normal line, you're going to take 30456, you're going to put it at the bottom of a fraction, so you're going to take 1, divide it by 30456, and make it negative. That's what you do. That is a negative reciprocal. A more general equation is that the the slope of the normal line is equal to -1 divided by the slope of the tangent line. That's it. So memorize that, write it down, write it on your hand before the test or whatever. Just, this is helpful, this is important, very straightforward. And here I have another example, right? Let's say the slope of your tangent line is a fraction, which it probably will be. That's usually how it works out. In that case, what you're going to do is you're going to reverse the fraction and make it negative. Or if it's negative originally, you're going to make it positive. So in this case, the slope of our tangent line is 5/2. So the slope of our normal line is -2/5. You just flip it and you switch the sign, and that's it. And yeah, that's all you have to do to find the equation of the tangent line.